Hello, everyone, and welcome to this webinar with Spectro Scientific and Mining Magazine, where we'll be looking at how to reduce costs, decrease downtime, and extend asset life with on-site oil analysis. First of all, I want to remind all our listeners that this is an interactive webinar. So on your screen, you'll see a light blue button that you can click to ask a question, and you can do this at any point during the event. If you have any technical problems during the event, you can click the red button marked Live Event Tech Support, and our team will get back to you as quickly as possible. In addition, the audio recording and the slides from this webinar will be available on the Mining Magazine website for all registrants in a few days' time. So to start off with, I'd like to introduce our speakers, who are Janet Keefe and Anton Marks. They will be talking about why oil analysis is the blood test for machinery. So it allows you to diagnose the health of the equipment and take the required maintenance actions. You will also learn how easy it can be to adopt an on-site oil analysis program with the MicroLab to develop effective asset management and maintenance programs. Janet Keefe is Global Product Manager for Spectro Scientific's Fleet Solutions product line, which includes the MicroLab Oil Analyzer, CoolCheck Coolant Analyzer, and the Fuel Dilution Meter. Her background includes extensive technical and business experience in the chemical and analytical instrument industries. And Janet graduated from the University of Vermont with a Bachelor of Science degree in chemistry and an MBA from Seton Hall University. Our second speaker, Anton Marks, is an asset management and condition monitoring professional in the African mining industry. So over the past 10 years, Anton has worked as a technical advisor for a number of multinational mining companies and co-founded Spectro Scientific's current representative in the sub-Saharan Africa, which is Atomic Oil. Anton graduated in mechanical engineering from the Central University of Technology in South Africa. So I will now hand over to our speakers who will guide you through today's webinar.
Hi, everyone. Thanks for joining us today. And just to begin, a quick intro of who Spectro Scientific and Atomic Oil is. Spectro specializes in instrumentation and software for on-site and in-field machine condition monitoring. We're one of the largest global suppliers of oil and fuel analysis instrumentation to a variety of industries and military worldwide. And Atomic Oil is one of our sales partners located in South Africa. So they supply and distribute our condition-based monitoring analysis equipment, and they assist clients in asset management solutions. So why would you test oil? There's a number of key benefits that fleets can achieve. The first being reducing maintenance costs. Looking at the condition of the oil allows you to do fewer oil changes. You're changing oil on an as-needed basis instead of just a time or mileage basis. The other advantage is to look at the equipment's condition. Oil analysis allows you to identify mechanical issues and can identify these and prevent unscheduled downtime and allow you to plan for outages. So that also improves the workflow, allowing you to see the degree of oil, the degree of maintenance needed, and allowing you to plan better. So there's a number of fleets that will use off-site laboratories to get this information. There are limitations associated with using off-site labs. The biggest one is the turnaround time. It can take days or weeks to receive the information back, especially for remote locations such as mines. And so, the maintenance engineer doesn't have the information needed at the time of the repairs. So you're also looking more backwards at oil analysis as a failure analysis as to what happened, and instead of using it as a predictive maintenance before issues occur. There's also times when, outside laboratories, they're not the ones closest to the asset. So there's a limit of understanding of what that asset condition is. So if the information is available right at the shop floor, they are able to look closer at that asset at that time. It also limits resampling possibilities. If there's issues that need to be looked at closer, to be able to send another sample out to an outside lab is an issue. And then data being accessible by the management, the hard copy report sent back from the lab doesn't allow a lot of trending and fleet information. So implementing an on-site analysis program is actually quite simple. All you need to do is pull an oil sample, then the operator would enter in the information into the MicroLab about what oil is being tested. Within 10 minutes, they can get a detailed maintenance recommendation from the MicroLab report and conduct those necessary maintenance actions. So when you're looking at oil analysis and what you can identify for your equipment, there's top 4 maintenance issues that we find in most fleets are oil properties. You're looking at either whether the oil is overextended or underutilized and can be continued to use. Also, wear metals is a big issue that we see. And the oil analysis can show breakdown from a variety of mechanical areas within the machine. Contamination is also another key factor that we see in oil analysis, either coolant contamination from a variety of sources or dirt contamination. So looking at one particular fleet, we can see this in this mining fleet over the course of a 12-month period. These are just some of the top issues that they identified with oil analysis. And you can see a number of wear issues that they saw and coolant leaks. And but the largest one is unnecessary oil changes. So almost 70% of their samples showed that the oil was actually still good at that time and could be continued to be used. This presents a really large savings opportunity for fleets to be able to extend that oil drain and save the cost of disposal of old oil and the labor charges as well. So looking a little bit at the MicroLab that allows you to do this on-site analysis, it's a cost-effective program, a cost-effective instrument compared to doing a full on-site oil laboratory. It's very simple. It doesn't require a special facility. It doesn't require a laboratory. It's usually placed somewhere just near, in a room near the workshop floor, and then there's no, it's all automated, so it's conducting 4 different tests of the oil, all automated, and then automatically cleans and gets ready for the next sample. So there's no special operators needed. There is no sample prep needed. It just takes a 5-ounce, 150 ml bottle to connect up to the machine, and then it runs through all of the necessary tests. The built-in expert system allows the interpretation of all of the data as well. And then there's also, we have online data and asset reporting systems. The MicroLab analysis gives a complete workup of the oil. You can receive the information about the serviceable life of the oil through chemistry parameters such as oxidation and nitration and total base number. It also gives you oil contamination information and viscosity. And then information about the mechanical issues of the equipment with a full elemental analysis up to 20 elements, showing you any breakdown of the machines and additive conditions of the oil. And particle count is giving you that information about any particle contamination within the oil. So the MicroLab report is a very simple report to read. It gives you all of the analytical data on the right-hand side, and it's showing up to 4 past samples. So it'll show you the current sample and 3 historic samples. So it allows the trending analysis of the machine. And then color-coded alarms alert the operator as to any conditions that need to be examined. And then on the left-hand side, you see the diagnostic statements. And this is interpreting all of the data results into mechanic statements that allows the operator to see the diagnosis and maintenance actions that are needed. So in addition to the MicroLab instrument, we have Lube Trak, which is a software data management system. And this allows fleets to look across all of the equipment. So the MicroLab gives a report that's telling the maintenance engineer what to do on that particular vehicle or component. And Lube Trak will allow that reliability manager to look across all of the equipment and determine what needs to happen for their maintenance program. And so essentially, Lube Trak is consolidating all of the individual reports into a data view, so it allows some fleet decision making. And then we also have dashboards with various views of graphs and charts of that information. It allows fleets to also have mobile access to any remote locations. They can view what's going on at a headquarters. And Lube Trak is also a customized system. So you can set up email alerts and custom reports and just allow you to look closer at your overall maintenance program. So with that, I'm going to turn this over to my colleague, Anthony Marks, who's going to take you through a case study for the MicroLab and how this was implemented at a customer in his region. Thank you.
Thank you, Janet. I'm going to share some of the information in the case study with you from a client of ours in our region. Obviously, it's a contract miner based in West Africa, and we did the case study on and off between 2012 and 2015. The project was done as part of a continuous improvement initiative to relieve some of the financial and operational pressures on the business. It was a very old contract, and it was dragging from year to year, so there was a bit of work to be done to make sure that the business makes money. During the case study, I'll take you through some of the detail, but in summary, we achieved, in terms of oil savings, doing oil draining extensions, we saved $166,000. We saved $696,000 by reducing our unexpected failures, and we saved about $86,000 by improving the hours that we get from the components. We also made a huge improvement to our parts exchange program in terms of value, And I would like to take you through some of the detail in the following slides. So key issues of asset management, I'm guessing this is the same for all the businesses, is basically income and expenses. In this sort of scenario of a contract miner, your key drivers would be your availability of equipment so that the production section can use the equipment and utilize the equipment, and other key performance indicators like your mean time between failures and stoppages are your key drivers in this sort of business. And the same as with any other business, you would always want to reduce your running costs as far as possible. And in this specific case, we focused on lubrication costs and we focused on component maintenance, which I will explain in the following slides. So in this particular project, we had targets, obviously, in terms of availability, utilization, and so on, in terms so that we can move a certain amount of product in a day. And in this case, effectively, we should utilize a machine 16 hours a day to achieve all of those relevant production targets. This business was based on a break-even plant model, where your costs basically determine your income, and the costs we derive from historical values and OEM recommendations. In this case, the plant was running on a dry plant rate, which means that the client supplied all the fuels, and in this case, the operators and all of the production staff was paid by the production section in the business. So it was a break-even model for plant or the engineering side. So all the profit in the business was made on the production side. In terms of maintenance and life cycle, the rates makeup, we focused on spares and lubricants and rotable reserve provisions, which is your maintenance reserve for spares and large components like engines and transmissions, and also for tires and all the other relevant rotables. Okay, in terms of income optimization in the plant business, I would like to show you an example here of a rate card, which is, as I explained, your expenses is actually your income because it's a break-even model. And the one thing that I want to highlight on this slide is on your top right corner is there's two portions of that makes up a rates card, and that's your fixed portion and a portion that's linked to the utilization of the equipment. Now, the importance of this is to show how important or critical it is to utilize the equipment and to optimize the utilization, because you'll still have a fixed portion of your overhead to pay regardless of running hours or not. And as you can see, between 55 and 65% of your costs are normally linked to utilization, which would be your lubrication costs, maintenance costs, and so on. And between 35 and 45% of this rate would not be linked to utilization. So it would normally be fixed expenses that you would have. So and that's why it's so critical to manage your income and your utilization so that you can cover the fixed portion as well. On the next slide, I've got an example of, or this is an actual example of availability of machines and how we would monitor that to ensure that you've got availability of equipment so that production can utilize the equipment to generate income. So highlighted in red in the middle there, I've got the daily and month-to-date availability of a loader number 3. So on the month-to-date availability, you can see that the equipment's available for 52% of the month, which is not very good because the target in this case is 90% because it's a prime mover. So on the right-hand side, we've got a table that indicates the potential gains and losses due to either good availability or poor availability. So in this case, we can see loader number 3 has a very poor availability, and we're using $28,000 month to date on that piece of equipment. I also highlighted the 773 truck fleet on this example. And if we have a look on the graph side, also highlighted in red, the month to date availability is 88%, which is above the target of 85%. And I will show you now on the next slide what the influence is of this loader on the trucks, because they work as a team, as a production group. Another thing that I've highlighted here, which I'll follow onto the next slide, is the drill rigs, where you can see obviously we're meeting all availability targets in this case, which looks good. But I'll show you now on the next slide on the utilization why we're actually not doing so well, or as well as expected. As mentioned, this is the equipment utilization graph that I've got on here. Now we've got the utilization month to date versus the availability month to date with the target. So as mentioned on the previous slide, we can see that the loader number 3 obviously was not available for production. And the knock-on effect we can see on the 773s that I mentioned, you can see on this graph, where the month to date availability is 88%, which is very good. We're hitting targets, but the effective utilization is only 42%. And if you have a look on the right-hand side, we're actually losing on that 773 truck fleet, we're actually losing $186,000 month to date, which is huge. And that's purely because of our own, it's our own fault, purely because the loader is not available to load the trucks. And I would like to show you the rigs as well. On the previous graph, the availability graph, we saw that the rigs was above target in terms of availability, but in terms of utilization, we're losing $237,000 a month. And in this specific case, it was due to the client not having a place for us to drill, so the drills were standing. And this is obviously quite critical. If you think back of the previous slide of the rates that I showed, where you have a huge fixed portion that you need to cover, and the drills are not working. So on this slide, I would like to indicate to you what the on-site lab mentored us and then helped us with when we installed it. So obviously we did a bit of homework, and it took some time to find our feet when we installed the labs. But on our prime movers, our excavators, and our main fleets, we saw a major improvement in our mean times between failure. What this helps, it's not, it's a KPI that's more about rhythm than anything else. And this really, really helped the rhythm of production, which helped a lot. And this, in turn, translated to better availability as well. And I'll show you in one of the slides to come how we got this results. So with better availability, from what we can see here, it's, let's call it 5 to 10% step up since we installed the lab at that time. But that 5 to 10% is worth millions of dollars, hundreds of thousands of dollars in production time. So on the next slide, we've got the piece of the rates card of a piece of equipment that maintenance actually has control over. So we basically have control over the spares, expenditure, the bins, the tires, the maintenance reserve, the labor, the workshop overheads, or some of it, and the lubrication costs. And on this case study, I'm going to go into the maintenance reserve portion, like I mentioned, which is the big engines, transmissions, final drives, and so on, which is included in the life cycle costing. And then also I want to focus on the lubrication costs and how we got that down. So in terms of lubrication costs, as we can see on the graph, the lubrication costs makes up about 12% of the portion of the rates card that we as a maintenance department has control over. We did an oil drain extension program to obviously save on oil costs or lubrication costs, but also to optimize the way we plan and the way we work on the equipment. So on this particular site, we focused on hydraulic transmission and gear oils as a start, and how we went about the whole project is we calculated the theoretical oil consumption, the baseline. We calculated the actual baseline based on a 6-month history, and then based on the oil analysis data that we had, we did a bit of analysis and a bit of stats to understand, what would be a safe drain interval for some of the components, and which ones we could just extend until the oil analysis told us to change the oils. Part of the strategy as well was to sharpen up the way we manage and control the issuing of oil on a daily basis. We implemented a pre-PM sampling practice where we would stop and sample the machine before PM service instead of on the PM service. And we also set up in our maintenance system that we use to plan services, we set up all of the compartments of oil compartments up as components so that we can track the exact time on oil changes or between oil changes. So to calculate the theoretical oil consumption, what we did here, obviously there's different methods of doing that, and which you can find all over the internet, but we took a more practical approach to this, and we looked at all of the different sump capacities and intervals that they needed to be changed. We added them together over a 2,000-hour period, which is not a normal service cycle on these big machines. In this case, we looked at the 777D dump trucks, and we added a 15% factor for the top-ups, leaks, and others. And we got to a theoretical oil consumption, which we can see on the screen. For hydraulic oil, we got 0.7 liters an hour, and for the transmission and gear oils, we got 0.93 liters per hour that we were supposed to use theoretically. Then we went through the history of the oil that we have issued over the 6 months leading up to the start of the project. So we could see that, reality paints a bit of a different picture. We were actually overusing on hydraulic oils, and we were looking quite good on the transmission and gear oils. And there's obviously always room for improvement. So, that is what we tried to do. But that was our baseline. Our baseline was 2.5 liters per machine hour, which is what we also used as a baseline going forward. So this is just a quick slide to show you how we managed and controlled our oils. We used proper controls when it came to tipping and meters of the tanks. As mentioned, we set up the compartments as components, which we tracked with work orders, as you can see on the sheet, so that we could understand exactly if oil was issued, where it was issued to, when it was issued, what it was issued for, and was it a service, was it a top-up, was it a leak of some sort. And we also made all of the supervisors accountable for the issuing of the oils to make sure we don't lose any oils to theft or any other funny reasons. Monitoring lubrication costs, what we did there is we monitored the oil consumption or top-ups over 45-day cycles. And that was just to sort of, focus on all the short-term issues that we had. Because obviously, it's old equipment, things were leaking all over the place. And so what we did is from the sheets and top-up sheets and workshop information that we got, we pulled all of that information onto one platform where we could track and trace, what was happening on the fleet. So, on the bottom half of the sheet, you can see that we basically compare two trucks there, also 2 777s. where we could see there were 16 counts of top-ups on the top one. 16 counts of top-ups in the 45 days, which is obviously not normal. And we had this little graphs on the side as well, which you can see there, where a user could quickly see where all the action was. So you could monitor the frequencies of top-ups. So on the top one, you could obviously see there's a lot of action, definitely abnormal action happening there in terms of top-ups and changes. And on the bottom one, on DT12, you can see, it's relatively flat. So you wouldn't have to focus on that particular machine. So on the top one, for example, now here, you would see there's a lot of top-ups. And then from there, we would drill into the details on the right-hand side of that little graph there. We would go through all of the different work orders of every single top-up and understand what was happening. And underneath that is also an example of how we would track the hydraulic hose usage, because that would normally link back to the oil top-ups and total oil consumption for a particular machine. On the pre-PM sampling, conventional, I think Janet explained this quite well. Normal practices on a mine would be, on a PM, you would draw a sample, you'd send it back to the office, you would consolidate, a whole box full of samples there and wait for a few days, and then you'll send it away to your commercial lab. They'll have it analyzed, they'll send it back to you, and if there's any issues, you would stop the machine. So we took a bit of a different approach there, where we did our oil sampling mainly on shift changes during a daily inspection or pre-shift inspection. And there was two reasons for that. Number one, to get the oil sample taken 3 days or whatever before an actual service, but also to influence the key performance indicators. And in this case, the mean time between a stoppage. So if we did an inspection or draw the samples during a production stoppage, which would be your shift change, that time is for free and it doesn't get included into the calculation. So we did a pre-PM, took the samples, we would take it to the lab, obviously send the machine out to work, analyze the sample, and if there's any issues, we would from there, address it at the service, which was also quite good because then it's not a stoppage for breakdown, it's actually just a PM service. And the great influence we had there was on the mean times between failure. Mean time between failure, mean time between stoppage. The big thing we also influenced there is we eliminated the double stop of equipment. So in the conventional way where you would sample during the PM, you would have to stop the machine in 2 or 3 weeks when you get the results if there's an issue. And the way we did it with the pre-PM, we eliminated the double stop by tackling the issues during the PM and not afterwards. So that obviously helped quite a bit as well with cutting down on the actual time that a truck would be in a bay to get serviced, because when doing a pre-PM, you would have the results available before the actual service. The planners would plan and create job cards for the compartments or sumps that had to be changed. And from the 9 components on a dump truck, we would, cut that down to normally, let's call it 3 or 4, depending on what the oil analysis said. So it had a very positive influence on the PM service downtime as well. So just in summary, on the oil drain extension, as I mentioned, on the PM service downtime, as you can see there at the top, we brought it all the way down from 6.8 hours, which was the average service time. We brought that down to, I think, 5.7 hours, which gave us an average saving of downtime there of just over an hour. And I mean, if you're not in the workshop servicing, the machine is available and it's getting utilized. It's earning money, which is good. On the costing side of oil, you can see that we brought, or basically saved over the 9-month period that we ran this trial, we saved $166,000 just by extending and servicing and changing oils we needed instead of on schedule. On the lubrication cost, there's a line there on the graph over the 9 months, and you can see per machine hour how we brought the cost down. And we ended up saving $1.80 plus per machine hour on this fleet. Okay, moving over to the component maintenance reserve section that I want to share with you guys. You can see that maintenance makes up around 35% of the expenditure that maintenance actually controls. And the maintenance reserve is basically an account where we capture expenditure linked to the big components, the engines, the transmissions, the gearboxes. And in this component maintenance reserve, we focused on premature failures. We focused on getting more out of our parts exchange program and improving our component performance. Okay, on the maintenance reserve or component reserve, I would like to show you an example of how you get to the maintenance reserve portion on a rates card, and how important the condition monitoring and oil analysis actually is when it comes to the maintenance reserve items. So as you can see at the top there, this is based on a Caterpillar 777D fleet, and you'll see the different frequencies of each equipment, the base price, and the rate per hour that you're supposed to charge. Now, in this example, I didn't include or consider, residual value of the component and what would be the best time to change it, or any escalations. I purely wanted to show you the consequence of not catching an engine failure in time. So on the right-hand side at the top of the table, you can see that the machine is scheduled to run 720 hours a month, 5,508 hours per annum. So in this case, where a machine is supposed to run 5,000 hours a year, and you lose the engine in year 2 instead of year 3 as planned, you will see there at the bottom that you will be $33,000 short. And I mean, all the components and rotables on the mining contractor site gets managed exactly the same. So, I mean, if you're under $33,000 on one component, it's very difficult to catch up to that cost, or you need to recover it from some other component that you need to extend past its budgeted lifespan in order to cover for this particular engine. And that's just to, create a bit of a background on the subject. So on this particular site that we had, our oil sample results took quite some time to get back. It was normally around 2 to 3 weeks, sometimes more. And over here, I've got on the right-hand side in the table there, I've got a list of components that we actually lost due to a slow turnaround time of samples. And we only looked at things like, the engine killers. We looked at soot, we looked at fuel dilution, overheating, oxidation, those sort of items that can actually kill an engine quite quickly. So you can see we reduced this failures by, let's call it 60%, because in the previous 12 months, we lost about $1.1 million due to these sort of failures. And after we implemented the on-site oil analysis program and we could sort of keep an eye on what's happening, we only lost 3 engines, which is not brilliant, but I mean, it's a huge improvement. And that equated to a total saving of $696,000, which is quite large in this sort of operation. In terms of our parts exchange program, we had to improve our balances. How a parts exchange program normally works for a contract miner is he would purchase a component like an engine example from the OEM, and part of that purchase would include a core value. So if you purchased an engine in a parts exchange program, half of that cost would normally be just a core value. So in essence, you would basically just pay half of the value of that engine, so you'd be paying for the repair of that engine. So what we did on this site, and was a major issue for us, is we tend, because of the slow turnaround time of oil sample results, we lost a lot of the cores that we were supposed to send back in good condition. And at that stage, we were $1.5 million in arrears on that account, purely because the cores that we sent back was damaged or had a complete failure. After installing the lab on site and getting into the swing of things, we reduced that value over that 9 months. Not reduced it, we opened or measured the account from that point. And over that 9 months, we only lost $94,000, which is also a massive improvement. In this case, it's obviously very difficult to quantify exactly what you saved, but I mean, you can see, there's a huge difference in the results over here. We also measured the component performance, which is obviously critical in this type of business, and we also used the 777 truck fleet for this. Over 10 months that we ran the program, as you can see there, we gained on some of the components in terms of the changing frequency, and we lost on others. Not sure exactly why that happened, but it did. But overall, we were up around 5% in terms of component life in hours. The actual hours into actual dollars, based on the pricing at that stage, you could see that we actually gained 8% just on that fleet. If you had to apply the same method or strategy across your whole fleet, and you did that from day one, I mean, the savings would have been huge. Like I say, in summary, in my opinion, if you adopt the strategy of on-site oil analysis and you integrate the technology into your daily operations, you will definitely see the benefits in your business. As seen from the data in the webinar, you will definitely see improved asset availability and utilization. You will definitely have an increase of income potential for your assets. You will be able to run an effective oil drain extension program, which is very difficult to do when using off-site lab, purely because of the time delays. You'll be able to streamline workflow in your workshops. You will definitely reduce your unexpected failures by having all these results on hand, and you will have a very good chance to increase the value of your parts exchange program. So thank you to everyone that listened to the webinar and tuned in. We will be taking a few questions now, and hopefully we can provide you with some decent answers.
Yes, thank you very much. That was a great presentation. We now have some questions from our audience on this topic. And the first one is, how many vehicles were in the case study?
Yeah, actually, a bit of a difficult question. Well, not a difficult question, purely because it was a bit of a mix. Like the oil extensions we did on, I think, 28 pieces of equipment, which was the dump trucks. The component extensions was also done on those 28 pieces of equipment, the trucks. The parts exchange portion was done on the complete fleet, and the premature failures was also done on the whole fleet, which is about 74 pieces of equipment.
And how big of a fleet do you typically need to benefit from using the MicroLab?
That's also that's actually a very good question. It depends on, for me personally, if you run a production group of a loader and a few trucks, it's a must, purely because of the risk factor. of losing one component prematurely, which could throw your whole business model out. So that's what I would say. One excavator, depending on the distance of your hauls, would normally run between 5, 6, or 7 trucks with a dozer or grader. So I would say, let's call it between 8 and 10 pieces of equipment. I will definitely start to look at getting a MicroLab on site.
And did the mine need to hire additional people to implement the oil analysis program?
In this case, not. We used the clocks that capture data to run the samples, and this served a bit of a double purpose, where we could get the clocks to fill in the information, plan the services, run the samples, and be included in the business cycle, and then also have the clocks to learn from the oil results and the statements that got spit out by the MicroLab. So, we didn't use any additional people for the study.
And then we have, is the MicroLab difficult to operate? So how much training is required to run the MicroLab?
Hi, I can answer that one. So the MicroLab is actually very easy to operate. It's fully automated, so it takes a lot out of the operator's hands. It typically requires, usually just a day of training from either Spectro or one of our sales partners, like Atomic Oil, and it's run by either some fleets will use their maintenance staff to run the analyzer, or sometimes they'll just use some support staff employee to run it. So it is very simple.
And what do you have to do to prepare the oil sample before you run it on the MicroLab?
Yeah, that's one of the benefits of it, is that there is no sample prep that's required. The mechanic would pull the oil sample straight out of the equipment into the sample bottle, and it just gets connected to the analyzer. So there is no type of sample prep required.
Okay, and how do you know if you can extend the oil drain?
Yeah, so as I had explained on when I was showing the report, it shows all the analytical data that would indicate the oil is still good, but for the operator, they just need to read the statements that say that oil drain extension can be considered, based on the analytical data.
So the next question is, the case study showed you extended the oil drain on the transmission, hydraulic, and gear oil. Why did you not also extend the engine oil? Can you test engine oils for drain extension?
Yes, that's correct. We only did the non-combustible components in the study, and that's because when we went through the data and analyzed the data that we had, we could see with the oil and the fuel that we were using there and had access to on a particular site, the TBM started breaking off, and the oil started degrading on the engines. So we didn't want to take a chance on the engines. So that's why we didn't do it on the engines at that stage. But sure, you can definitely extend the drains on engine oils if you have the correct oil to do so.
Okay, then we've got our last question. What information does Lube Trak tell about the equipment that the oil report does not?
So Lube Trak is an additional software database, and it will actually give the same information as the oil report directly from the analyzer. It just allows a fleet supervisor or fleet director to further analyze the entire fleet information. So it's just compiling all of that data, the individual data, into a different system. So it's a separate system that is available for people to purchase outside of the MicroLab.
Okay, thank you very much. Our time is just about up, so I'd like to thank our speakers, Janet, Kievan, and Toa Marks, for giving us a good overview of this topic. I'd also like to thank our listeners for taking the time to be with us today. Please do look out for the on-demand version of this webinar on the Mining Magazine website. That will include both the audio recording and the presentation slides and will be available to everyone who is registered. It will go up on the website in a few days' time. You're also welcome to keep sending questions in, and we'll do our best to get some responses to you. So thanks again to everybody who took part in today's webinar with Spectre Scientific and Mining Magazine. I hope you enjoyed it, and goodbye for now.